In this video, we will look at the GeoJSON file format. GeoJSON was developed for representing geospatial entities with attributes. It is an open standard. Geospatial entities are entities that have a geospatial location. It is most commonly used for 2D data. There are three main types of geometric entities: points, polylines, and polygons. In the geospatial context, polylines are called line strings. Aggregations can be created of each of these types of entities. These are called multi-points, multi-line strings, and multi-polygons. Geometric entities are wrapped in another type of entity, called a feature. In the geospatial world, features are any types of things that can be mapped. Point features can be used to describe things like addresses and locations. Line string features may be used to describe things like streets and bus routes. Polygon features may be used to describe things like building footprints or countries. Features contain two types of data: geometry data and attribute data. The geometry data we have already mentioned. The attribute data consists of a set of key-value pairs. In GeoJSON, attributes are called properties. The file format stores each feature as its own stand-alone entity. The data inside the features are totally independent from one another. The geometric entities in the feature will be defined by a set of coordinates. These coordinates are contained within each feature and cannot be shared. The diagram shows three features: a line string, a polygon, and a multipoint. Each feature has a set of coordinates. GeoJSON files are saved as text files. This means that you can open them in a text editor and inspect the contents. The file uses the JSON format, which is a popular lightweight format for storing a wide variety of different types of data. The JSON format defines a nested dictionary data structure, containing a series of key-value pairs. In the example, the file contains a single feature. The geometry of the feature is a polygon. Note that some of the coordinates have been omitted. For properties, we can see that the feature has two properties, called prop0 and prop1. Polygons can have multiple holes. If polygons have holes, the list of coordinates will be nested. The first list will be the outer exterior ring. Subsequent lists will be rings defining holes. The GeoJSON specification includes geometry collections. In theory, these would allow features to be defined that are a mixture of points, line strings, and polygons. In practice, support for geometry collections is rare. For example, QGIS, a popular open-source GIS application, does not support it. Note that hierarchies of collections are not supported. In other words, collections cannot contain other collections. One key limitation of the GeoJSON format is that it does not fully support 3D modeling. In most cases, GeoJSON is used for 2D data. Some limited support for 3D is possible. Coordinates can include a third component, for the elevation above a reference level. This can be useful for representing things like topography, as long as there are no concave features. In addition, entities can have attributes that describe some aspects of the 3D form. For example, polygons can have a height attribute. A volume can then be generated by extruding the polygon by the specified height. In general, GeoJSON allows arbitrary semantics to be applied to geometric entities. This type of approach is common in the geospatial domain. However, the flexibility of how this semantics is applied is quite limited. It is not possible to represent hierarchies of collections. There are no topological entities, such as vertices, edges, and wires. It is not possible to have welded vertices, which makes it difficult to represent connectivity between entities. And it is not possible to have attributes on positions, vertices, edges, and wires. The coordinates in a GeoJSON file are geographic, not Cartesian. Each coordinate consists of a longitude, a latitude, and an optional elevation. The longitude and latitude are in degrees. The elevation is in meters. For longitude, the values range between -180 and 180. For latitude, the value range from -90 to 90. The geographic coordinates allow geometric entities to be defined for any point on the Earth's surface. The system that is used is called the World Geodetic System. It is often necessary to translate between the geodesic system and the Cartesian system. For example, GeoJSON data may be translated into a Cartesian coordinate system. Or the data from a Cartesian coordinate system may need to be translated to GeoJSON. In order to be able to translate the data correctly, the Cartesian system must be geolocated. For the origin of the Cartesian system, a longitude and latitude must be defined. The diagram shows an east-north, up coordinate system. The y-axis is pointing north, and the x-axis east. The z-axis is pointing up. If it is preferred, the Cartesian coordinate system can also be rotated around the z-axis so that the y-axis is not longer pointing north. Once the coordinate system is geolocated, the data can be automatically translated. When trying to geolocate a Cartesian coordinate system, Google Maps may come in useful. Clicking any location will give you the approximate latitude and longitude of the location. Later, we will see how this can be used in order to geolocate a Möbius model.